Okay, section 6.5, the sampling distribution of a sample mean. So again, hopefully, finally, this emphasizes to you guys that not every problem involves the letter P for proportion. Some problems are mean problems. They're problems regarding the average. Okay? So again, I think we get so proportion happy that we lose sight that means are different things. Okay? All right, so let's talk about a couple things. First of all, when you're looking at different types of data, so for instance, categorical data, so groups of things, or yeses and nos, that kind of thing, that's where you use proportions. But when your data is quantitative, meaning it's a number, it's a measurement, and you can take the average of those numbers, then it is a mean question. All right. When you're looking at the sampling distribution of the sample mean, that symbol is x bar, right? Sample mean describes the distribution of values taken by the sample mean x bar in all possible samples of the same size from the same population. So again, when we look at the interpretation, you'll see we use those words in the interpretation. So again, eventually we're going to use a normal distribution. And to do that, we need to talk about the mean and standard deviation. Here's your symbolism, right? This mu sub x bar is the mean of the sampling distribution. The sigma sub x bar is the standard deviation for the sampling distribution of x bar. So again, suppose that x bar is the mean of a sample drawn with size n from a larger population with a mean of mu and a standard deviation of sigma. The mean of the sampling distribution, mu sub x bar, is going to be equal to that population mean mu. The standard deviation of the sampling distribution of x bar is going to be equal to this formula. It's the population standard deviation divided by the square root of n. So it involves the sample size. All right, so a couple things about the behavior of x and how it's much like that of the p hat, right? So comparing x bar to p hat, number one, x bar is also an unbiased estimator. The mean of its sampling distribution, mu sub x, is equal to the population mean. Mu sub x bar is equal to mu. Number two, when you're talking about the standard deviation, it's the typical distance between your sample means and your true mean of the population. So remember that mu is the true value. And it's how much do our sample values compare or deviate from the true value. Number three, the sampling distribution of x bar is less variable for larger samples. Again, we talk about the greater the sample size, the smaller the variability. And lastly, again, independence is required. Again, we ignore if the sample size is less than 10% of the population size. So again, that's usually a given. Okay. All right, so let's take a look at our first example. So it says the number of movies viewed in the last year by students at a large high school has a mean of 19.3 movies with a standard deviation of 15.8 movies. Suppose we take an SRS of 100 students from the school and calculate the mean number of movies viewed by the members of the sample. Calculate the mean and the standard deviation of the sampling distribution of x bar. Okay, so they give us the mean of 19.3 movies and the standard deviation of 15.8. So our mu is 19.3 movies. Our standard deviation is 15.8. And we are looking at samples of size 100. SRS is of 100. Okay, so to find the mean of our sampling distribution, to find the mu sub x bar, it's equal to the mean of the population, 19.3 movies. These always have units, so make sure you include them. I'm going to be a stickler. Make sure you include units. And then the standard deviation for your sampling distribution of x bar is going to be equal to the population standard deviation divided by the square root of n. And I'm just going to do that in my calculator here. So 15.8 divided by the square root of 100. And that's 1.58, and that'd be movies. Again, use your best judgment. 3 decimals, potentially 2 to 3 decimals would be fine, and that'd be movies. And there you go. Okay, so then part B says interpret the standard deviation. So again, this is where we talk about all possible samples. So we are doing this. So we're just going to say if we took all possible samples, took all possible samples of size 100 from this large high school. So that's the start of it. Then we're going to say what we're measuring, the sample mean number of movies viewed in the last year, right? The number of movies viewed in the last year, viewed would typically vary. Here's your standard deviation words, typically vary by, and then you put your standard deviation of 1.58 from the true mean of 19.3. There we go. Okay, so again, remember the standard deviation of the sampling distribution is how far your sample means vary from your true mean. And that's what we said right here. Notice I did not put the units here because they are here. Number of movies, right? Number of movies. So you don't need to be redundant. Now, if it's like a length and it has like centimeters or inches, you should put those. Okay. All right, great. That's objective 1. Here comes objective 2.